Hello everyone, this is Akushan from Twitter. Today we're going to talk about calculating HDD0 and HDD1 offsets and also the sizes on a NAND PS3 HDD backup. The requirements are the backup.image, which is obtained by using a tool called HDD raw copy tool. Um, you can find it on the internet in the hddguru.com/software. You can see it here. Uh, you can go here and download the Windows installer if you want to use it. If you prefer, you can just use the Windows executable, which is for the portable version. Both will work the same. Then you will need the EID root key, which is obtained via custom firmware such as rebug or evilnat. Rebug is more recommended for the Decrypt models because there's only a Decrypt variant for rebug. Evilnat is recommended for any retail or test kit model. Then you will need SSLs or Sorvigolovas PS3 encodec tool. You can find it here. I will also leave the links in the description. Let's see here. You can see here in the bin folder, inside the release folder, you can see it has the executable here. You can use it natively. It's a command line executable, so I will show you how to use the command line with this. And you will also need HXD or any other X editor. I prefer using HXD to take a look at the offsets from the XML editor. And of course you will need a calculator to calculate the offsets. Windows calculator is sufficient for this, so if you go here and you type calc, you can find a calculator here and you can use this calculator. So the first step is to extract from the backup.image the partition table. So that should be simple enough. So you know this is a NAND PS3 HDD backup, so it's a FAT model. So you do well. I have already moved the PS3 encodec to the user local bin folder of my WSL distribution. So if you have it next to you, like here on the desktop, the PS3 encodec, you can just do move PS3 encodec.exe / user / local / bin, and it will be moved to the binaries directory, and you can use it directly. So I already have done that. So the first thing you need to do is type ps3 encodec.exe to know how it's used. And yes, and of course you will need WSL to make this easier. So as you can see here, it shows the usage ps3 encodec.exe. -h is the help, -e is to encrypt, -v is vflash, -p is fat, and -a is arcade, so for arcade models. -s is the start of the sector, and -n is the number of sectors. Then you have obligatory arguments such as the root key file, the sector file, and the out file, which is not obligatory, but it will produce a file if no such out file exists. I don't remember the name, but it should be called something like out.bin. So first things first, you type in the desktop. So since the backup.image and the root key are in the desktop, you type ps3 encodec.exe minus p because it's a fat model. This is from a Decrypt, so you know it's a fat model. It's not vflash, so we will not use vflash. And we will type minus s0 because the start of the backup it's at 0 sectors, and minus n 8 because the partition table has exactly 8 sectors or 0x1000 bytes. And then you type the ID root key as parameter, backup.image as the input file, and out.bin as output file. For ease of naming, you can just type partition underscore table dot bin, and it will produce, I believe. Yes, okay. You can see here in the partition table that is decrypted. If you compare, you can see this is encrypted and this is decrypted. You can see here at 0x30, you can see the first start of the HDD0 partition. So the first start is at offset, no, not offset, is at offset 08 in number of sectors. So if you go here to our lovely Windows calculator, you can just go here to hex, and we know that the sector size is 200 in hexadecimal, and you multiply by 8, which is 0x1000. So we know that HDD0 has 0x1000 as offset, and we also know that the size is this value multiplied by 0x200. So we go here and we type 2E53908, and we multiply by 200, and we get this value. So we just copy this value, and if we go here to the backup.image, if we go to 0x1000, and if we select from here, length will be this, we can see it stops at the determined point where you can see the zeros. So this is the point where HDD0 begins and ends. So you can do that, and you can grab your HDD0. However, I do not advise that you use this on any computer. Instead, you should use the DD tool, which I should also put here in the txt. So DD tool to copy specific regions of the backup file. So we know that HDD0 is located here. So let's see where HDD1 is. So we go again to the partition table, and in the partition table the offset for HDD1 is at 2E5390B8 times 0x200. So if you go here and we put 2E5390B8 and we multiply by 0x200, we get the offset for HDD1. And we know that the size is 3FFFF8 times 0x200. So if we go here, not in the partition table, but in the whole backup, and if we go here, we should have ending of zeros and beginning of something encrypted. So we know this is the HDD1 where the update files are usually stored. So, for example, if we want to extract the HDD1, just a little bit of this part. What should we do? We divide this again by 200. Okay. So we know it's 2E5390B8. We can grab, for example, of this sector, we grab 0x1000 bytes, just so we know we are on the right track. And we just click new and we paste it here. And we type file, save as, and we put here HDD1 test.bin. Okay, so it will be created here in the desktop. Then we need the offset for sectors in hexadecimal, which is 777228472, and we do the same, but instead of using sectors start as 0, we use 777228472, and of course number of sectors 8. But instead of backup.image, we use HDD1 test.bin, and the out we put HDD1 out.bin. Okay, so now we wait. It will decrypt, and if everything goes right, we should see a FAT32 partition. And there it is, the FAT32 no name HDD1 partition. So as you can see, our HDD is decrypted. You can see here the magic bytes that mark the start of an I believe it's MBR partition, which is the HDD1, and you can also use this to extract HDD0 and to extract any other partitions that you might want, and to manually analyze the file. I have done a few tests in the past. For example, this one, dd if backup, which is input file, it's backup.image of equals hdd1.bin. Block size is equal to 4096. I will explain in a bit. So if you go here to the hex and you multiply this by 200, again to get the HDD1 offset, we know that the offset is this one, but we want to simplify using DD. So the first thing we do is to find the lowest number denominator for for the offset. So we see here that we have 0x7000. So we can do something like divided by 0x1000, which we can see it's 4096. And this will give the number 97,153,559. So as you can see here, and if you use this command, you can be sure that it will back up the entire partition of HDD1 and skip the first sectors of HDD0 with 100% certainty. So if you do this command, you will produce a file called HDD1, which will be the correct partition, and you can then use that file to then decrypt it later if you desire. There's also another command that I believe I got here, but for example, here, this one, ps3 minus p minus s, and then we specify only the start of the sector, but we don't specify the number of the sectors. We specify the root key, we specify the binary file with the partition for the HDD1 that we produced before, but in this case we haven't, but it's likely we did. And we specify um, the output binary for the decrypted HDD1 partition. So we get a decrypted HDD1, and then we can use, for example, 7-zip to extract any files that we might have, or if we want to go manually analyze it, we can also do that and take care of that ourselves. Anyway, that's all for today. I hope you guys enjoyed this little tutorial about the PS3 HDD encryption. I'll try to do another one with NOR and not FAT models in the next time. Goodbye for now.